Today we're going to be working on cardinality into our Excel formula book. So we talked about cardinality as being the size of the set. You'll see these kind of looking like the N on the outside. Think N as being a number. Excuse me. Because our previous section in chapter 6.1, we talked about how to make your set. So now we're looking at, okay, well, given that you've made the set, can you then count up the values? So we had these two equations to start. We had union and intersection, which you have these equations, given that you know N of A, N of B, and either or. So let's take for this example, this really quick one. We said N of A. So in set A, we have A, B, C, D. So we have four terms here. N of S is the total. So we have A, B, C, D. And again, you have B, which is B, C, D. So then we need E, F. So we have 4, 5, 6 in total. Now B, we had 1, 2, 3, 4, 5. And that's just coming from here. And all we're doing is we're just counting up. So now let's say we have A union B. So union is another way to say or. We said, okay, well, in class we could, if we wanted to, build the set, and then any sort of repeated number we can cancel out. Or we can use your equation. Your equation, since we don't know we're working on this one. So if we have A or B, if this is unknown, this is where your formula is going to be. So I'm going to cancel this out. I'll just put none here. So we can say, okay, well, in order for us not to know this union, we can figure out your intersection. Your intersection is A and B. Well, what do A and B share? Well, A and B shared B, C, D, B, C, D. So there's 3 elements that have been repeated. And you'll also see them here being repeated in this red that we then block out. So we said equals, and then for us, we're going to take N of A right here, N of A, plus N of B, and then minus, not that one, minus the 3 that have been double counted. So in total, we should have 6 elements that are shared in A or B. Now let's try it again with this one. So let's say that this is the one that we want. And maybe that I scoot this down and put it down over here. So if I wanted to go in the reverse, if I wanted to know A and B, right? So if I have this unknown, what I could do is the opposite. A and B is equal to all of A plus all of B, and then minus the overlapping, and I'm putting it in the wrong one. I'm sorry. We should say minus this value here. So we'll say equals all of A plus all of B minus C8. Sometimes when they're right next to each other, you don't get to click on the cell. So C8 being right here. And so if we knew what your OR was, your OR is just counting them all up. So it's A, B, C, D, E, F. So that would be the 6. Again, we would already know it to be 6 to be true here. And so you have it built in. So let's say we did that again. So let's say we have this problem in example 1. We have September 2015, a search on Wiki for the phrase asteroid threat yields 9 articles. So let's change this to 9. And notice by doing so, it changes here as well. Containing the phrase William Burroughs leads 30. Then it says a search for the articles containing both phrases yields 2. So is that going to be going in the or the and or the or? Well, both means and. So we know 2, right? 2 of them will be over counted, like repeated. So therefore, we will have 37 at the end. So this is just kind of have to like, you need to kind of figure out, well, what is known or unknown if you have an and or do you have an or. Let's try it again once more. Now we're going to go on to the complement here. So it says the complement of a cardinality. So if we have n of not a, so it looks like this little like apostrophe symbol, it's really like a prime symbol. And so it's just talking about the complement, not. So we say is equal to n of s minus n of a. That way, if you take a and you just cancel it all out, you should be left over with everything that's remaining. So if we were to do it from before, right, your answer doesn't quite make sense. So let's try it again with this one right here. We have n of your s is a, b, c, d, e, f. So we have 6. Your a is equal to a, b, c, d. So that's 4 elements here. We don't know what b is. We don't really care in this context. But we're going to take the 6 and we're going to subtract the 2 that are overlapping. Or sorry, the 4 that are overlapping to get the 2. Now let's use that context for example 2. It says, in September 2015, a search on Amazon found 65,000 cookbooks. And we're going to label cookbooks. So in total, we have 65 cookbooks. So 65,000 cookbooks. Lots of cookbooks. Of these, 14,000 were regional cooking. We'll just say ours is going to be A. So we'll do 14,000 is regional. We have 5,000 were vegetarian. We'll just call that B. And it says, and 17,000 were on either regional cooking or vegetarian or both. So it says either or both is 17. So do we have a known and or a known or? So this 17 is an or. So we have this value here, 17,000. Notice that we have 2,000 that are therefore double counted. Now, do we want this? Right, well, it says how many of these books were not both regional and vegetarian cooking. So when it says not both regional and vegetarian, that would be this total 2,000 amount. So to get rid of that double count, right, instead of having our A right here being the opposite, we're just going to take our total and subtract it by your unknown. So we should get 63,000 63,000 cookbooks that are not considered regional or vegetarian. So for your complement, you might need to swap some of these values. Notice that by just clicking and deleting, you might be just going back to what we need initially. So I'll just say minus this 2,000. I think that will conclude it for today. Oh, we're going to actually talk about your Cartesian product here. Your Cartesian product is just taking A times your B. So for these examples down below, we have A, B, C is set A. So we'll do set A here as 3 elements. And B here, let's say B or N of S, let's just count them all up. 1, 2, 3, 4, 5, 6, 7. B is 1, 2, 3, 4. We don't need any of this. We don't even need this. What we're going to be going down to is here, this product. So it's saying we have equals 3 times 4, A times B. Now this will shortcut it for us. So if we did it again over here, if we toss a coin twice and observe the sequence of heads and tails, how many possible outcomes are there? Well, your coin toss, right? You have 2 of the same options. So we would have 2 options here. And notice that it's multiplying and it's getting us 8, which we know the answer is 4. But this is just saying in your first coin toss, we have a heads and a heads, or a heads or a tails, right? And then we toss that same coin twice. So again, we get those 2 options out. So if we got all of our options together, it would be heads, 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 tails, tails, heads, and tails, tails. So in our case, we're not going to be multiplying by B. Instead, we're going to be multiplying by A itself. And if we were to now toss it 3 times, right? We're going to take this sample space, these options, and then tack on an additional roll. Now, by doing so, it's not just going to come up with just 4 more, right? It's just going to give us, well, not 4 more, but like it's not just going to add a value onto these. It's going to come up with 8 different possibilities because we take the same coin A and we toss it once. You have 2 options. We take the same coin again, toss it again, another 2, and then one more time, another 2. So we're multiplying 2 here 3 times. So we'll go over here and say, we'll multiply again by 2. Now there is a shortcut because instead of multiplying it by itself like 10 more times and then just clicking and going, what we can start to build is if we're doing an exponential, you can say we have your options here as 2 and raise it to the number of coin tosses or the number of questions or whatever the context of the problem is. So if I were to build it over, and I'll just snap this back to the original here. Oh. You could say we have the options or the number of options, then the number of tosses, or you could say, okay, maybe a different question, we have the number of options and the number of questions. So we'd have equals the number of options, right? Well, we have 2 options, and actually we don't need to do the equal sign, right? The number of options on a coin is either heads or tails. And the tosses here, well, the toss you can either do 2 times, 3 times, 10 times. Let's do 10 times. And so when it does the outcome, we're going to take the number of options here and raise it to the number of tosses. So we should get 10,024 or 1,024. Now, if we were to do something a little differently, let's just say we had a multiple choice question, right? And let's see, on your multiple choice, you could select either from A, B, C, or D, right? Well, of these options, there are 4 options available to us in question 1. In question 2, again, we have A, B, C, D. And let's say we have 3 questions. Question 3, we also have A, B, C, D. So each question, we have 1, 2, 3, 4 options. And let's say we continue, we now have question 10, right? Well, let's say we have 10 questions. So again, when we do the outcomes, how many different ways could we answer this? We could say is equal to the number of outcomes raised to the number of questions. And you'll see here it's a very large number, and that's all right. Perhaps, no, there's no real one that's a nice one, right? But this is what we could do if we had something that is reoccurring multiple times. And I'm going to get rid of this.